And the next step we want to do is, so we have a matrix multiplication. A lot of times neural nets also add in a bias. So we're going to add in another function that's a mat dot plus the bias. It'll be very similar to the mat dot function. Essentially, we can copy this and paste it in there. Into a search that bias dot. Let's see, how do we want this? Bias.calls should equal destination.calls. I think that's how we want it. And what we can do here is, instead of making that equal to 0, we will make it equal to bias. So typically when you're using a neural net, your output, your destination is going to be one in a normal dense neural net. It's going to be a one row by number of neurons for each sample. And we'll just make that 0. So that'll be for each sample. We'll leave that like that. Okay, cool. So really, that's the only change for the bias, for adding in the bias, because you set the destination, matrix, location has the bias, and then you add in the matrix multiply, which typically it's viewed the other way around, is you do the matrix multiply and then add in the bias, but same thing. So if we were to go back here, we will make a matrix bias equals mat. So it's going to be always a 1 by, and then be the same as the destination columns. So 1 by 4. We can change this to a mat dot bias. Need to fill in some number for the bias. I'll say 1.5. So instead of 6, each one should pop out 7.5. Yeah, perfect. Let's see. Okay, now as long as everything's working for you, you can move on to the dense layer, which will use all of these matrix operations. So we'll just make a new file, and just call it NN. First we'll have a layer dense. Okay. Let's see some other things. Checking my notes. Some other things I'd like to have. Oh yeah. There we go. Include a couple other things. Eventually, might want to do some stuff with time. I don't think we'll need that actually. That was more for some tests I was doing. Okay. And here we're basically, I'm just going to make everything public within the class. I feel like that helps for more experimentation in the future. Sometimes I might want to mess with different things, like directly mess with the weights. It's just easier, faster way of getting into that rather than going through more formal stuff. Alright, so for a dense layer, you're going to need the number of inputs, number of outputs, knowing whether we're going to have a bias or not. And let's see if that's it. And number of samples, number of inputs. Let's see. Okay, I mentioned just the input dimension. Yeah, I like that better. And then you obviously need a forward, takes in inputs, and then you'll need a backward, which we will get into in the next video. We'll get into that. D values is the next layers or next portion of the neural net's derivative values coming back through the previous layer, back to this layer, which is the previous layer, is what I mean. And then we need output matrix for the output, matrix for D inputs, which is what you'll pass to a previous layer, which, so let's say this layer is the T layer. The T minus 1 will get D values, which is this T layer D inputs. So if we're on the third layer, we'll pass back D inputs, which will be the D values for the second layer. Derivative of the biases. We'll do this a little separate. Weights. Derivative of the weights. Put the biases there. Biases. And then a bool for the layer bias, which will be populated with this. So basically saying whether we want this layer to include the bias or not. We need a matrix for layer inputs. Which is just a copy of the inputs you get here through the forward pass, because you'll need that in the backward pass. And transpose of those layer inputs, which later on, I think in the backwards pass, we'll be making another matrix operation for transposing matrices. Yeah. All right, so So input dimension, which so the input dimension is the let's say this is the input. So input dimension would be this. And then, so this would be one sample. This would be a second sample. So input dimension going down this way would be the number of samples. The in out would be the number of outputs, which would be the number of neurons. We're using a bias or not, and int num samples. So have our in samples. Number of samples in there. Alright, so the number of samples equals num samples. Layer bias, copy out the bias. This way we can use it in the forward and backward passes, knowing what we're doing. The weights, input dimension. Okay, so I like to allocate all of these matrices here in the declaration of the, or in the, when you first create the layer, because it's faster for memory writes rather than if you were to create the matrices. Well, for the weights themselves, you would create them here anyways, but something like the output, I'm going to create that here, allocate it here in the constructor, because that is faster than if you were to create a tensor or create a matrix in the forward pass and then send it to this output and create a new matrix every time you're going through the forward pass and then deleting it. So I just create it once and override the output data every time through the forward pass. But yeah. So we'll initialize the weights. And you can change what the initialization is depending on what you're going to be doing it for. Let's see. So we do also want, we're going to want a transpose of the weights later on. So yeah, we're going to allocate all that stuff now. And this will be helpful in the future when we go to the backward pass. So the weights are a input dimension by output dimension, so the transpose will be output dimension by input dimension. And then if we have layer bias, we are going to allocate the biases and such. Again, so we don't have to generate memory every time we go through the backward pass in the for loop. Just set it all here. We can overwrite those values. It would be faster in terms of memory read and writes. So yeah, the weights are input dimension by output dimension. You have the rows of the input, which is the number of samples, by the input dimension, and then you need input dimension by the number of output of the weights. So when you matrix multiply, you'll get the number of samples by the number of outputs for the output. And this is just to copy make a copy of the inputs that you put in through the forward pass so that you can use it in the backward pass. Which I guess another way you can do that is you could just make an extra parameter in the backward pass of the inputs and send that through there, but yeah, we're not going to do that. We're just going to make a copy and keep, which I guess could be slower. I keep messing this up because in my notes I wrote it down as number of inputs, and I just decided to change it here to input dimension. So that's why. Okay, so yeah, the input will have number of samples by input dimension. The weights have an input dimension by number of outputs. So the output has the rows of the input, which is number of samples, and it has the columns of the weights, which is number of outputs or number of neurons. And then next we can go ahead and go to the forward pass. Which takes in the inputs and it's actually pretty simple. The code for this is pretty simple. Like I said, we're gonna copy the inputs and if we have a layer bias, if we have decide to use bias, we're gonna do the function match dot bias output inputs weights and biases. Else we are going to just do a mat dot output inputs and weights is all you need there. And that's it. Now we can just go ahead and try this out here. Let's see. There we go. Save that. Go here to back to the main file where we're going to test it out. So what we could do is just keep the A and we'll delete all this. So instead of matrix ops, let's see, we got that in here. So we will just include that instead. We'll have a layer dense and just call it LD. And we need input. Let's see. So we need the input dimension, which is 3. Let's do this. Put dimension equals 3. Let's see. Samples 2. That way we can just change this to num samples and input dimension. We'll also have the number of neurons equals, let's say 4. Yeah, okay. So here we will have input dimension, input dimension. We will have num neurons. Bias, let's start with that equals false. And number of samples will be number of samples. We have ld.forward on A. And then we'll go ahead and print out the output, because we saved the output in the class. So print that. Let's see what comes up. Let's see, yeah. Helps to fill this with numbers. Do that. And since the weights were a bunch of really small numbers, we got this bunch of really small numbers. Let's try it with layer bias true. So we're adding in a bias term. So we can keep all the numbers consistent. So yeah. And that is the forward pass.